Okay, welcome to the second video on algebra with problems. In the previous video, we um, solved algebra with problems that related to journeys, basically. These questions today are about those algebra questions that involve mensuration. So you'll see different shapes coming up and different perimeters and areas and so on. So let's start solving. This is a pretty old question. This is from June 2003. It says the diagram 1 shows quadrilateral ABCD in which DA equals to AB equals to X and BC equals to CD equals to Y. I've told you that there are two angles that are 90 degrees. I see a kite basically. Show that the area of this quadrilateral is XY. So I don't have a direct way of calculating the area of the kite. So I'm going to divide it into two spaces and say that these are two triangles. I can add up the two triangles. So area of kite is 2 times area of triangle. So I have then 2 times half times base, which is y, and height, which is x. So that gives me xy. So that is the area of the quadrilateral. It says 5 of these quadrilaterals are joined together to make the shape shown in diagram 2. So 1, 2, 3, 4, 5. The total area of the shape is 80 centimeters square. Show that the perimeter P of the shape is given by. And perimeter means the outer boundary. So let's count the x that we have. 1x, 2x, 3x, 4x, 5x, 6x, 7x, 8x, 9x, and 10x. So I know that my perimeter will have 10x, and then it's also going to have two y's only. Why? Because I'm just talking about the outer boundary. I will ignore these lines because perimeter does not mean internal boundary. It means only the outer boundary. So I'm going to say that it's 2y. But you see the perimeter here doesn't have y. So what do? I try to make a connection between x and y. I have this piece of information. So what am I going to do? I'm going to say that there were 1, 2, 3, 4, 5, 5 shapes. So another equation that I have is 5xy equals to 80. If I divide 80, 5 on the other side, I get xy equals to 16. Now, can I replace y with 16 over x? I'm creating a substitution out of here and replacing it here. Let's see if we get our desired answer. That's what I was trying to prove. So I get 16 over x. That gives me 10x plus 32 over x. So I have the perimeter that the question was asking me about. Since I didn't have y, I created a substitution for y, and then I've used it in the next part. That's part 1, b1. Then we have b2, and we have a after that. In the case where p equals to 38, so 38 equals to 10x plus 32 over x. Show that the equation this. So what I want to do is I want to bring an equation in one line and say that it turns into a quadratic equation that looks like this. I think that's easy. Instead of taking an LCM, what I'm going to do is I'm going to move this to the other side and then cross multiply x. I get 38x minus 10x square equals to 32. I've cross multiplied x. I'm going to bring everything to one side. 10x square minus 38x plus 32. Can I factor out a 2? That gives me 5x square minus 19x plus 16. When this 2 goes to the other side, it becomes 0. So I have my proof. Okay, then B, solve the equation 5x square minus 19x plus 16 equals to 0, giving both answers correct to two decimal places, then again it's a simple question on solving a quadratic equation. So I'm going to say minus b plus minus root of b square minus 4ac over 2a. Okay, then putting all of this on my calculator. So I get x equals to 2.54 and 1.26. Okay, so those are the two values for x. Let's find the two possible values of y. I think that's simple. I had this, I can use this. So y equals to 16 divided by 2.54 and y equals to 16 divided by 1.26. 6.30 and 12.7. Okay, calculate the value of p when x equals to y. Okay, so when x equals to y, what changes is I will have a difference here, and I'm going to say that in this equation it's going to become 5x squared, 5x into x equals to 80. So 5x squared equals to 80, and then x squared equals to 16, and x equals to 4 or minus 4, but I'll just take 4 because minus 4 is not a length that I could use. Okay, and once I have that, I can go on and calculate this. So 40 plus 8 is 48. What is the special name given to the quadrilateral when x equals to y? So if your x is equals to y and all these angles are 90 degrees, the other angles will also turn out to be 90 degrees. And then what you have is a square. Why? Because when sides are equal and the angles are 90 degrees, you have a square. Those are the properties of a square. So that was an entire question on algebra and mensuration. Let's see some more. It says in the diagram ABCD is a rectangle. AB equals to 12 and BC equals to 8. AB equals to BQ. All of these lengths are given to you that are equals to x. Okay, find an expression in terms of x for the length of QC. So QC looks like it's simply 8 minus x. The entire length is 8 and the length above is x, so 8 minus x. The area of the triangle CRQ. So area of this triangle, that's what I'm asking you. So I'm going to say that area equals to half base into height. Okay, that's the area of triangle. See, I don't need to multiply this right now unless the question says so. And show that the area and square perimeters of the quadrilateral PQRS. Now, when I'm talking about the area of PQRS, I'm talking about this internal area. How I can find it is if I were to subtract these four areas, A1, A2, A3, A4, from the entire rectangle. So I'm going to say that PQRS is equals to area of A, B, C, D minus 2 times CRQ minus 2 times, um, let's call that PBQ. Okay, I'm saying that I have two triangles that look like this, that's PBQ, and I have two triangles that look like that, that are APS and CRQ. So it's ABCD. ABCD is just 12 into 8, which is 96. I just calculated CRQ. So I'm using that. And PBQ. Let's look at that. So PBQ, if I look at that, this is the height of PBQ. So half base into height. So height. And then let's put the base. What is the base? It's just 12 minus x, because on the other side also I have x. So I'm going to say that it's just 12 minus x. I'm sort of running out of space here. I'm going to take this and move this down here so that you can see it clearly. Okay, so the 2's cancel out, the 2's cancel out. So I have 96 minus, this is x into 8 minus x. So I'm going to first multiply 8x minus x square inside the bracket, and that's 12x minus x square. So the 96 minus 8x plus x square minus 12x plus x square. So I get 2x squared minus 20x plus 96. Yes, that's what the question was asking. And it says when the area of the quadrilateral PQRS is 60, form an expression in x and show that it simplifies to this. So when PQRS is 60, so I need to use the previous part, and I'm going to say that 60 equals to 2x squared minus 20x plus 96. Moving everything to one side, I get 2x squared minus 20x plus 96 minus 60. Square minus 20x plus 36 equals to 0. Factoring out a 2, I get x squared minus 10x and 18. So 0 over 2 equals to x squared minus 10x plus 18. Okay, then part D says solve the equation this, giving your answer correct to 2 decimal places. I think that's simple. It's just a quadratic formula, so I'm going to say that x equals to minus b plus minus root of b squared minus 4ac over 2a. Then punching all of this on my calculator, I get 7.65 and 2.35. So 7.65 or 2.35. Then it says it is given that this is equals to that. Find the value of k. Now, this question is about completing the square. So if you are aware of how to complete the square, you can go ahead and do that. What I can do in this question is there are two ways of doing it. Well, if you're given the form, it's very easy to, sort of just do a comparison between the two forms, and a lot of things will start canceling out, and you can end up with the right answer. In case you want to complete the square, you can watch the entire video that is there on my channel, and that will help you complete the square. So in this case, I'm going to keep it simple. I'm going to say that this is equals to that. So what happens if I expand the right hand side as well? So a square minus 2ab plus b square plus k outside. So 2x square minus 20x plus 50 plus k. 2x square minus 20x plus 96. Okay, so if you notice, if I move things around, you will notice that 2x square minus 2x square minus 20x plus 20x and 96 minus 50. So k is therefore 36. Then it says hence write down the smallest possible area of the quadrilateral PQRS and the value of x at which it occurs. This is a question on quadratics that you study at O level as well. So you have this. This is called the completed square form, and the coordinates of the maximum and minimum points can be seen in these brackets, and you can say that this value inside the bracket, this expression inside the bracket helps you calculate the x coordinate. So 5 is the value of x, and what is the maximum value? This is an expression for the area. So the maximum value of the area is 36. These are basically the coordinates of the turning point of your quadratic expression, and you must have studied this in the chapter on quadratics, although it's not in as much detail in O levels, but yet there is a part of quadratics that asks you to calculate the maximum or minimum values. Okay, so moving on to the next question then. This is more about circles and triangles. Let's see what the question is about. It says AM is a point this and AB is a tangent at A. AM equals to y centimeters. Okay, so this is y. And AB is y plus 5, and MB, this is the entire thing MB. Okay, which is y plus 9. Show that y squared. So I can see that there is a radius and a tangent, right? So this has to be also 90 degrees. Show that this. So I can just use the Pythagoras, and I can end up with an answer. I can say that the hypotenuse squared is equals to the perpendicular squared plus base squared. So I get y squared plus 18y plus 81. Y squared plus y squared plus 10y plus 25. Okay, so y squared minus y squared. Oh, okay, there are two y squares. So let's first add them. Let's first simplify the left hand side so that it's easier for us to predict which side we have to go to. I think we move everything to the right hand side. So y squared minus 8y minus 56 equals to 0. And to solve the equation, I think I can easily solve this equation by using the quadratic formula. So minus b plus minus root of b square minus 4ac over 2a. Let's see. Let's try solving our quadratic equation. 1 minus 8 and minus 6. Okay. So I get 12.5 and minus 4.5. I think those are the correct answers. Yes, those are the correct answers. Then it says find the length of the longest side of the triangle ABM. The longest side is obviously the hypotenuse, so that's going to be y plus 9. So I'm going to say that's 12.5 plus 9, and that should give me 21.5. Okay. Then part B has a lot of circles and triangles, and it looks a little overwhelming. Let's try to do that. I think we should be able to sort that out. Our points in the circle center O, QT is a tangent. So QT is a tangent. So the angle that it's making here should be 90 degrees. That's what I've written down. So this angle should then be, if you look at this triangle, I think it's going to later ask me to prove that. Okay, show that QRS equals to half of 90 minus. So I can say that if this is 90 and this is x, then this third angle must be 180 minus 90 minus x, as in the angles of a triangle. So this angle is 90 minus x. Okay, then we have the property of the circle that says that the angle formed at the center is twice that at the circumference. So in order to end up at the circumference, I'm going to do half. So that is half of 90 minus x. How do you show this? You basically show this calculation that I've shown you. Okay, and then you can write down that QRS is half of QOS, so half of 90 minus x. Find an expression in terms of x for OQS. Okay, so I want this small angle. Now I know that These two angles that I've marked in red will be equal. Why? Because it's an isosceles triangle that I'm looking at. So I'm going to say that, let's call that angle something. Let's call that y. Okay, I think y hasn't been used. So 90 minus x plus y should equal 180. So 2y equals to 180 minus 90 plus x. So 2y equals to 90 plus x, and y equals to half of 90 plus x. That's a strange conclusion, but yes, that's the correct answer. It is given that QRS, so this one is three times QRS. So 3 times QRS, let's write that down, is twice of OQS. So the one that I just calculated. What was QRS? I proved that in the first part. So half of 90 minus x. And OQS, that's what I proved in the second part. So 2 times half of 90 plus x. Okay, show that this. So let's try and see if we get the right answer. Okay, so 3 over 2, 90 minus x equals to 90 plus x. I'm going to cross multiply the 2 and multiply by 3 on this side. So 3 times 90 is 270 minus 3x, and that's 180 plus 2x. Do I have the right answer? Yes, that is what I was asking you to prove. Hence, find QTO. No, QTO. Where is QTO? QTO. So that's finding the value of x. Okay, I have an equation. I can just shuffle things around and find QTO. 270 minus 180 equals to 2x plus 3x. So 5x. X equals to 18. Yeah, with the calculator, 18 degrees. That was another question. There was more space to it. I didn't really realize. Let's move on to the next question. Now it says evaluate this. I think I can do this pretty quickly on a calculator. Okay, so I can do this pretty quickly on my calculator. Let's do that. Make sure that you calculate as in degrees. If you're an advanced student, you might have it in radians. So 8 sine 54 divided by sine of 18. That gives me 20.9. Three significant figures, yeah, so that's the correct answer. Then I want you to evaluate this expression. I think that's also simple to evaluate. Sine 43, that's 4.61. Okay, then this question is more about trigonometry than mensuration. Let's try to do that because I see some bit of trigonometry being involved. It says in the triangle this, form an equation in x and show that it simplifies to 3x squared plus 9x minus 247. Okay, now what do I do if I want to connect these three? This is not a right triangle because the question doesn't say so. So what I can do is I can immediately start thinking about, I have three sides given to me and I also have one inclusive angle. So that means I must incline towards the cosine rule, and that's what I'm going to do. I'm going to apply the cosine rule. I'm going to use that angle here. I'm going to say that the side opposite the angle, so it's basically c square equals to a square plus b square minus 2ab cos of c. So I'm going to not follow ABC that way, but I'm going to say that this is the side that I'm going to use. The other two sides are x square and 2x plus 3 whole square into 2x plus 3. Now whatever side I've kept here, the angle opposite that must be called C. So this is the angle I'm talking about. So this is cos 60. Now, there are lots of common mistakes that happen in calculations, and when students do it, please make sure that you're careful about them. Let's move that down because I think I'm going to run out of space here. Okay, so 256 x squared plus 4x squared plus 12x plus 9 minus. Now remember that you can't subtract first and then multiply by cos 60. You have to make sure that you multiply by cos 60 first. So I'm going to write 2x into 2x plus 3. What is cos 60? Cos 60 on my calculator gives me half. So cos 60 is half, so that cancels out the 2. So I'm left with 5x squared plus 12x plus 9 minus now 2x squared minus 3x. Let's see if we get a correct answer. 5x squared, no, that's 3x squared, 5x squared minus 2x squared plus 9x plus 9 minus 256. Does that give me 247? Yes, I think that gives me 247. So minus 247 equals to 0. Okay, solve the equation this. That was the proof. Common equation in x. Solve the equation this. So I'm going to solve the equation. I'm going to say that 3x squared plus 9x minus 247 equals to 0. So minus b plus minus b squared minus 4ac over 2a. Let's solve this. And gives me 7.70. X equals to 7.70 or minus 10.70. Okay. Hence write down the lengths of AB and AC. So AB is X. So that's 7.70. I can't use the negative one, that's obvious. And AC, that's 2 times 7.70 plus 3. Let's put that on a calculator. 18.4. The answer seems to be messed up here. I don't know why. Okay, find the area of the triangle ABC. So then I can use area equals to half AB sine C. So half, I'm going to use this side and that side and the angle 60. So 7.70 into 18.4 into sine of 60. So we get the correct answer. I'm getting 61.3. And yes, that's the correct answer, I think. Yeah, 61.3. So that's the area then. Moving on to the next question, I have question number 12 here. It says A, B, C, D, and PQRS are rectangles. Each rectangle has an area of 13 centimeters square. So the areas of the two are equal. That is what I can predict. AD equals to x and PS equals to x plus 5. Find in terms of x an expression for AB. Okay, so the area is 13. Can I call this the length? So XL equals to 13. So L must be 13 divided by x. Similarly, let's call that L. So L into x plus 5 equals to 13. So L equals to 13 divided by x plus 5. Okay, given that AB is 3 centimeters greater than PQ. So AB is 3 plus PQ. So AB is 13 over x equals to 3 plus 13 over x plus 5. Form an equation in X and show that it simplifies. To this, I need to cross multiply and solve, and whatever the question may be asking me, let's take a common denominator here only. It might simplify calculations. So I get 3 times x plus 15 equals to plus 13 equals to 13 over x. Then cross multiplying again. So 3x into x plus 5 plus 13x. So I get 13x plus 65 equals to 3x squared plus 15x plus 13x. So I see 13x on both sides. Can I just get rid of that? But C says solve. So in every question you'll see a quadratic equation being solved. I think it's the same process. Minus b plus minus b squared minus 4ac over 2a. 2.78 or minus 7.78. Show that the perimeter of ABCD is 14.9. Okay, let's talk about perimeter of ABCD. So I have two lengths and two widths. I think that's a simple question on perimeter of a rectangle. So 2L plus W. The interesting part is that I don't have L. I need to find that. So I'm going to use which value of X? I'm going to use the positive value of X and say that this is 2.78, 2.78 as well. Let's see if we get our required answer. Now, in these questions, I don't really have to show you working beyond this. I can just put all of this on my calculator, multiply by 2 and see if I get 14.9. Yes, I'm getting 14.9 centimeters. Find the difference between the perimeters of the two rectangles. I can find the difference between the perimeter. I can calculate the other perimeter in front of me. I'm going to say that the perimeter of, what is that? It's PQRS. 2 times L plus W, so 2 times 13 over x plus 5 plus x. Okay, so I'm getting, okay, that's also x plus 5. Yeah, that's a mistake. 18.9. Difference is then 4 centimeters. Okay, so the next question is this. It says rectangular paving slabs measure x centimeters by y centimeters, where x is less than y. 14 of these slabs form a path around each of the two different rectangular gardens. These two gardens are shaded in the diagram below. The outside perimeter of the design is 10.2 meters. Okay, so I'm not talking about centimeters anymore. I'm talking about meters. I could make this equation in two ways. I could convert this into centimeters, and I think that's the easier way of doing it. That you multiply this by 100 and say that it's 1020. Okay, and the other should be 1360. Okay, then it says the total perimeter is this. Show that there are two equations. So I just need to construct two equations, and it's important to realize that the perimeter of this block might be the original small block might be different from 14 blocks being put together. So I'll have to count the x and y's. So let's count the x first. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8x. How many y's? 3, 4, 5, 6, 7, 8, 9, 10 equals to 1020. So I think that is going to be the first equation if I factor out a 2 and move it to the other side. So 4x plus 5y equals to 510. That's the first equation shown. Let's talk about the next one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12x, y, 13, 16. Uh, and the total perimeter of the design in parts 2. Okay, so this is saying total perimeter. So I also see this bold black line inside. That's interesting. So there are more y's than I thought and more x's than I thought. Let's erase this. So I was in 12x, 13, 14, 15, 16, 17, 18, 19, and 20. 20x and 8y. Now what do I see common? I think I can factor out a 2 from this side. Let's see what 1360 divided by 4 is. If it is 340, yes, that is 340. So 5x plus 2y equals to 1360 divided by 4. 5x plus 2y equals to 340. Now, even if you weren't able to do these 2 marks, you can still go on and solve the simultaneous equations, and that shouldn't be a problem at all. You can solve them with elimination, substitution, whatever you want. I am going to, I think, use elimination only because it's going to create fractions when I do substitution, and that's going to be more challenging for me. So I'll multiply this entire thing by 5 and this entire thing by 4. That's the coefficient of x that I'm using. So I end up with 20x plus 25y equals to 2550, and 20x plus 8y equals to, I think that was what I factored out, so that's 1360. So subtracting these two, 17y, 2550 minus 1360 gives me 1190, and then 1190 divided by 17 gives me 70. So y is 70. Okay, and x, I can use any of the equations to calculate x. But find the difference between the areas of the two gardens. Okay, so areas of the two gardens, I will have to calculate this garden and that garden separately. So design 1, area of design 1. Remember that I'm calculating in centimeters square. At the end of the day, I am going to, in fact, can change it initially or can change it at the end. That's my choice. So let's first focus on the area. So that gives me 2x and that gives me 3y. So it's 2x into 3y, that's 6xy. Area of design 2, that's y into 4x, so y into 4x, that's 4xy. I can calculate first the difference and then substitute the values. I think that's an easier way of doing it. So 6xy minus 4xy gives me 2xy. Then I plug in the values of x and y, 40 and 70. And this is in centimeters square. How do I change it into meters square? I divide both of these by 100 or divide by 100 twice, and that should give me the final answer. Let's see if I am right. I think I'm right. Yeah, 0.56 meters square. Okay, moving on to the next question. This is a numbered. This should be question number 14, but I think question number 14 is this. Let's call that question 15 then. Okay, doing 15 first and then 14. A piece of wire 28 centimeters in length is cut into two parts. One part is used to make a rectangle, and the other is um, square. The length of the rectangle is 3 times its width, so 3x. The width of the rectangle is x centimeters. Write down an expression in x for the length of the rectangle, so I've written 3x. Find and simplify an expression in terms of x for the length of the side of a square. So what I have to find out first is, since it doesn't say I've cut it equally, so I can't do 14 and 14. I can just say that if I subtract whatever is consumed in the rectangle, so what is consumed in the rectangle, there's an x consumed, there's an 3x, there's another x, and there's another 3x, so that's 28 minus 8x together. Okay, that is the entire length that I have left over for the square, but I want just the length of the side, so I'm going to say that 28 minus 8x divided by 4, because 4 equal sides. Okay, so that is 28 minus 8x. We could factor out a 4 from the numerator, cancel it out, and that would give you 7 minus 2x, and that's also absolutely fine. I'm going to do that later on. It is given that the area of the rectangle and the square are equal. So area of the rectangle is length into width, and that's side square. So length was x, width was 3x, or the other way around, and this was 28 minus 8x divided by 4 squared. Form an equation in x and show that it reduces to this. The intelligent thing to do here would be to factor out this 4 and cancel it out. Why? Because it's going to make calculation easier. So 3x squared and then 49 minus 2ab plus b squared. So I get x squared, 4x squared minus 3x squared minus 28x plus 49. Let's see if we have the right expression. Yes, we do. Okay, and just solve. So part 2 is solve minus b plus minus root of b squared minus 4ac over 2a. That on a calculator. It's 26.1 and 1.88. Which solution represents the width of the rectangle, giving your answer, giving a reason for your answer. Okay, so the idea is that the width of the rectangle is x. So what value of x fits? The problem with the larger value that I supposedly see is here. If I do this, 8 times 26.1, this length is going to become negative. And I can't have a square with a negative side. So I'm going to say that which value fits 1.88. because 226.1 makes the square impossible. Okay, because it has a negative length. So then can I calculate the area of the square? Yes, I can do that. I can just say that it's 7 minus 2x whole square. 7 minus 2x was the length of the side, as you can see here. That's what I factorized. So in the last part, I just have to uh, put in the value and square it. Okay, it should give me 10.6. Let's check. 10.49. Have I rounded off too much? That's 10.5. I may have rounded off somewhere, which gives me a slightly different answer from what's there in the marking scheme. But I'm sure there's tolerance there. Okay, moving on to the last question for this marathon. Um, let's do this. It says ABCD is a trapezium with AB parallel to DC, DC equals to 15 and AB equals to X. The perpendicular distance between AB and DC is 3 centimeters. Less than the length of AB. So this is X minus 3. The area of ABCD is 75, so I know that I want to calculate the area for trapezium. Area of trapezium is half height into sum of parallel sides, 15 plus X. So 150, and then cross, and then expansion. Yeah, that is giving me the right answer. Find AB, giving your answer correct to one decimal place. I think that's a quadratic. I can solve that on my calculator quickly. I'll find the it's minus b plus minus b square minus 4ac. We've done that so many times now. So I'm just going to skip the calculation here because I'm short of space as well. So that's giving me, one is giving me a positive answer 9.19, 9.20 basically. So let's call that 9.20. That's the value for x that I found from the quadratic solution. Okay, AD is 0.8 centimeters longer than BC. So AD is 0.8 centimeters longer than BC. Ah, that's weird. Given that the perimeter of the prism is 38.0, calculate AD. Okay, so let's call that y. This must be y plus 0.8 then. So I have 9.20 plus 15 plus y plus 0.8 equals to 38. To y equals to 13, y equals to 6.5. Let's check. That is the correct answer. So calculate AD. AD should therefore be 6.5 plus 0.8, which is 7.3, I think. Is that the correct answer? Yes, that's the correct answer. Then says another trapezium has LM parallel to ON. The reflex angle LMN is 252. This doesn't look like a question of an algebra, but I'm just going to sue on and solve it. MNO. Okay, so this, remember that angles between parallel lines are supplementary. Uh, the reflex angle element. So it's not the obtuse angle element, it's the reflex angle element. So it's the angle at side, and I want to calculate this. So I'm going to say that the first thing that I need to do is 360 minus 252, and that will give me 108. So that's 108 inside. Now these two angles are supplementary, so that should add up to 180. So that is going to be 72 degrees, and 108, 180 minus 108 basically. So it says the ratios of the angles inside the trapezium LON, LON, and LMN are 1 is to 2. So they are in the ratio 1 is to 2. LMN is 108. So LON over 108 equals to 1 is to 2. Can I calculate LON then? LON is easy then, 54. And then OLM and MNO are 1 is to K. Find okay, I found this, so I can find that as well. So that's 180 minus 54. What's 180 minus 54? That's 130 and 126. So 126 to MNO. MNO is, I just found out in the previous part, that's 72. Or in the ratio 1 is to K, I want to find out K, so I'm going to say that's 72 divided by 126. 72 divided by 126 is indeed 4 over 7. Okay, that brings us to the end of this series. I will be back with algebra word problems that are not really mensuration or trigonometry or um, journeys as before. They will be different there sometimes, but sort of number patterns or things like that, and we will solve them together. Make sure to like and subscribe and follow me for more videos.